All right, well, thank you for joining me for this session. This is work that I've been doing with my colleague Sawood, who's from the Internet Archive. My name is Mark Phillips. I'm at the University of North Texas. And the work that we're going to present here is the hosting of the end-of-term web archive data in the cloud. So for those that don't know, the end-of-term web archive is an initiative that began in 2008 with the transition from the Bush administration to the Obama administration. It is a collaborative web archiving project with a number of partners over the years, and we have successfully created a web archive containing the 2008, 2012, 2016, and 2020 presidential transitions. And in the years when there actually wasn't a presidential transition, we used it as a way to create an archive, a snapshot of the United States federal website, what we generally refer to as the .gov space. That content has been housed at the Internet Archive and is available through the global Wayback, but we have been interested in making this more broadly available. And so the work that we're doing with this project was to focus on the computational consumption of the project. And this is challenging because currently the size, the scale of the collections are very hard to work with, and access has really been focused on end user access that want to use the Wayback interfaces, but is not as easily done through any sort of computational means. There are a number of other goals of this, which you can see on this slide. But moving on, the framework that we used for this work is actually based on the work that Common Crawl has set up. And for those that don't know, Common Crawl is a 503(1) nonprofit that's really dedicated to providing a copy of the internet for internet researchers. They do a monthly crawl of around 300 terabytes. They use Nutch for their crawling. They store their data in work formats, and then they openly share that content through Amazon Web Services' Open Data Sponsorship Program. The web crawl data is familiar content formats for us in the web archiving community. Work files are the primary data, and then they also create the WAT files with extracted metadata, WET files containing extracted text, primarily of the HTML and TXT files. And then they also have a unified CDX index using the zipnum format. And then they also generate a Parquet index which is a column-based format. So the reason that we chose to use this Common Crawl data structure is to try to leverage existing tools that they had already built so that we could capitalize on those in our project. They were built around working with large data sets, so we knew that they wouldn't have any problem with the end-of-term work. We also thought it would be great to try to leverage any of the existing Common Crawl community who are big users of their data sets to try to have them come over and use the end-of-term data. There's also the ability to reuse documentation about the formats, the code, and the processes that exist already in the Common Crawl space. And we decided to take the mindset of if we don't have a good reason to deviate from this pattern, we might as well use the pattern. So generally the structure, all of the Common Crawl data is located in a Common Crawl bucket on Amazon Web Services, the S3, and it has a kind of a nested hierarchy in the URL that kind of follows what you can see on the screen, where within the crawl data folder, which is kind of the main data, you have each month of a crawl, and then the segments within that. Segments are a holdover from, I believe, the Nutch crawling process, and where it distributes the content across many machines, and then that's replicated within the segments. And then within each of the segments, there are different folders to contain different kinds of files, with works, WAT, and WET being the ones that we're primarily looking at. So we ended up mapping kind of the space we were thinking about into this really easily with making use of after the crawl data, we were able to then separate out the 4 different crawl periods that we did with end of term 2008, 12, 16, and 20. And then we used the segment notion to actually document the crawling institutions. So an example that we have in 2008, we see the California Digital Library, CDL, and IA. And then if you look within a segment folder, for an example is the CDL-00, you see CDX files, a folder for CDX files, WARC files, WAT files, and WET files. There's another companion component to this at the overall crawl level, which would be the indexes, so the zipnum indexes and the Parquet indexes, which we're currently hosting under kind of the very same path, even though it has some holdovers from the common crawl namespace, such as the CC index. So we'll be seeing if that's actually going to be what we do at the end on our end. So what exactly are we moving? We're trying to create a working a full copy of all of the end-of-term crawls in the S3 system. And so we've kind of split the work up with 2008, 2012, where UNT Libraries has a complete copy of both of those collections. So we're going through and doing that data. And then the 2016 and 2020 is being done at IA because they have that full step. And so the steps, identifying the collection within our own respective repositories, staging and verifying, actually uploading into the, or organizing it into the bucket layout that we've just previously mentioned, which we generally just refer to as that common crawl structure, generate any of the derivative files that we need, and then we upload that to S3 and then document the data set. The logistics so far, just kind of how this project got started. Both Mark Graham and myself contacted Amazon Web Services Open Data Program in the fall of 2021. It was very quickly approved by the Amazon folks as saying, yes, we want to move forward with this. The IA, the Internet Archive, is the institutional home for the accounts that we work with, and we use shared credentials with different partners. So I have shared credentials on their hosted a S3 bucket. And then currently we have kind of an allocation of around 500 terabytes of data in S3, which is being picked up by the Open Data Program. And if we need more, we just have to ask, but they've initially allocated around 500 terabytes, which should be close to what we need footprint-wise. We've had early conversations about the opportunity of making use of some compute resources, but we haven't really communicated what we would need on that if we needed to do any processing in the cloud. And then since November, Sawood and I have had weekly calls to kind of keep up with the planning of this and figure out the little components that go along into making the whole. So decisions that we've made along the way that I think are really important for this community to understand. So we made the decision early that we did not want to do any conversion from ARC to WARC. And that mainly happened, or it only happened in the end of term 2008 content when we started off with ARC crawling, and then we made the transition to the early, very early versions of WARC. We decided not to do any renaming of files, except in the very, very small situation where there were duplicated names, file names with different content. I think that happened in about 40 files in 2008. And then we also decided not to do any concatenation of small files into larger files. And so we decided that we didn't, so we wanted to keep the WARCs as kind of the primary data, and then any derivatives that we needed to make. There were some additional metadata fields that we wanted to be able to add to our final Parquet format, things that we're not collecting that we've seen become very useful for analysis from the common crawl side of things, including language information of the content-based language identification, content-based format identification, and also character set identification. And so we've been kind of approaching that with a tool that is being developed here at UNT called our WARC metadata sidecar, which really just creates metadata-based WARC files in a very similar way as WET and WAT files, but just really have the small fields of the content-based derived metadata. So language, character sets, and formats. We tried to keep all of the segments in groups of basically 10,000 works, just to make sure that there wasn't an overwhelming situation if you tried to download a whole segment. And it just kind of keeps things easier for us to manage bucket-wise and moving things around, or folder-wise. In addition to the formats that Common Crawl make available, we also made available the CDXJ files at the work level, in addition to the zipnum index. And we also went with the approach that this would be an iterative improvement process. So we wanted to get all the data into S3, create derivatives, create metadata improvement, and then improve the resulting Parquet file over time, instead of waiting on perfection before we moved things online. So far, the data movement has been, the biggest challenge at the beginning was actually identifying the boundaries of the end-of-term crawls within our respective repositories. It's sometimes a lot more challenging than you would expect. Many of these crawls were spread across 100 or 200 archival information packages within our respective institutions, and making sure that we could actually put hands on those and then bring those in. We had to dive into some old large CDX indexes to kind of get an idea of where we were going with things, so we didn't miss anything. So we took the approach of kind of divide and conquer, where UNT and IA would take different sets of the end of term with, as I mentioned earlier, UNT with 2008, 2012, and IA doing 16 and 20. And then we took slightly different approaches, where UNT, we had access to a small Hadoop infrastructure that we made use of. So we uploaded both the works and the derived metadata files, works, the watts and wets. And then IA, we're actually just uploading the works directly, and then the derivatives will come later, most likely either created in the cloud or pulled down onto a local Hadoop cluster here at UNT. So progress so far, the end of term 2008 and the end of term 2012 have been fully loaded. Just shy of 17 terabytes of works for 2008 and about 45 terabytes of works for 2012. We're working on updating the website to describe the data sets a bit more, but you can go to that link right there, and that will get you access to the data. I've got a few screenshots to show you. So this is the main end of term website talking about the project, and up in the top right corner you'll see a datasets link. And if you click on that, you'll see the 2 data sets that we have available currently that are complete. And when you click on one of those, you get to the data set, which then kind of mimics the organizational structure that Common Crawl provides, and kind of gives you files that there's list files for all of the subcomponents. In some, in this one, there's about 125,000 WARC files, and then their related WET, WAT, and CDX files. We also did a nice little proof of concept to show that we could run PyWB from Amazon Web Services directly, and it only took about 15 lines of configuration, and we got both of these hosted on Amazon Web Services. We had a very small server locally here at UNT, and we loaded up Python Wayback and did the configuration, and were able to serve very quickly from the cloud, which was cool, and just making use of that zipnum format. And so just to demonstrate that it worked, these are screenshots from the 2008 White House, and then this is a screenshot from the 2000 and what would have been the 2013 White House. I seem to have gotten off on my slides a little bit. Sorry about that. So next steps on this. We're working on the transferring of the 2020 data from IA. Where, like I said, we're moving the work data first, and then we'll generate the derivatives afterwards, either locally or in AWS. And then we'll move back into the end of term 2016, which was a bit stranger in putting boundaries around. It included some FTP content, actually quite a bit of FTP content that was crawled by archive team and stored in works, which have some interesting challenges in this whole space. And then once all of those are there, we'll begin the metadata enhancement work that we wanted to do for the legacy ARC and work data to extract the language information, the content-based MIME types, and character set information. And then we will continue documenting the data sets, and we're interested in setting up a CDX index server for providing Wayback interface, probably with PyWB for all of these collections, pulling off of the AWS data. And then the final piece is really kind of is working with researchers and community in the different communities to try to encourage them to make use of these data sets, answer any questions, and understand how we can improve the content so that they can be more useful for their research. So with that, I'm thankful for the work that Crom and Crawl did so that we could leverage that. I'm really thankful for the Amazon Web Services open data partnerships so that we can actually host this data in the cloud. And we're happy to kind of discuss this later at the full event in a few days. So thank you very much.